In this lecture, we will discuss about normal distribution. So normal distribution, this is very powerful distribution in statistics. This normal distribution is also called a Gaussian distribution, also called Gaussian distribution, or this is also called the limiting case of binomial distribution, also called limiting case of binomial distribution. So we will discuss later about this limiting case. Now, so first we know that the distribution, normal distribution is the continuous probability distribution. So we also remember this thing. This is a continuous probability distribution. Continuous probability distribution. So now we define this distribution as a continuous random variable. A continuous random variable x is said to have a normal distribution. Normal distribution with parameter mu, that is mean, and sigma square, that is variance. So it has a probability density function PDF function x fx with the mean mu and sigma square. We write down 1 upon sigma root 2 pi e raised to the power minus 1 upon 2 x minus mu upon sigma to the whole square. So this is the probability density function of normal distribution. So where the random variable x, which is lie between minus infinity to plus infinity, and the mean mu, we also say that which lie between minus infinity to infinity, and a sigma, which is greater than 0. So sigma represents the standard deviation that will be positive. So basically we have two parameters, mean and variance. So this is the probability density function of normal distribution. So with respect to random variable x. So the value of pi value is 3.14 approximately. Now, when we understand the concept of mean mu, so first thing we have the word normal. Normal, so we can say that the normal curve. Normal curve means the mean, median, and mode are equal. That means the curve is symmetrical about the axis. So suppose this is our horizontal axis. Now we draw the curve. So this is the curve. So which is normal. about the mean mu. So we say that this side is plus infinity and this side is minus infinity. Now we talk about the some figures. That means when we consider two different mean. So suppose we are here, that means we draw two normal curves. So first curve we have considered this side and second curve we have taken as this. So in this curve, so that means here we take as this is mu1 and this is mu2, or this is a sigma 1 and this is sigma 2. So the curve which represent the standard deviation on the basis of standard deviation. So in this we see that the sigma 1 is equal to sigma 2. So that means the standard deviation is same, but the mean of both the datas are not same. Mu1 is not equal to mu2. So we show differently. Okay. So now second example you can consider as, so suppose we are drawing the graph in this form. So when this is our mean mu1, so this mu1 is equal to mu2. We are taking two different datas. So we both having the same mean, but standard deviation are different. Standard deviation are different. So we can draw such type of graphs. Okay, so this is the representation. So the standard deviation shows the data dense. Now, so the representation basically of a normal distribution, that we can represent this as random variable x follow the normal distribution with two parameter mean mu and variance sigma square. Variance sigma square. So this is the basically representation. Mu x follow the normal distribution with parameter mu and sigma square. Now we are going to convert this random variable x into standard normal variate z. So let the standard normal variate z. So we put z is equal to x minus mu upon sigma. So x minus mu upon sigma. So with the expectation of z, or mean case, this is the mean is 0, and variance of z is equal to 1. So mean 0, variance 1. So we can write this as z is normally distributed with mean 0 and variance 1. So mean 0 and variance 1. So we can represent the probability density function in terms of z. So this can be represented fz. Fz is equal to 1 upon root 2 pi e raised to the power minus z square upon 2. E raised to the power minus z square upon 2. So this is for standard normal variate z. Now, so when we are going to calculate the probability of interval x1 to x2, so that means finite interval is given. So we can calculate as integration from x1 to x2 into fx dx. So fx dx sigma into root 2 pi e raised to the power minus 1 upon 2 x minus mu upon sigma to the whole square into dx. So basically, we have some properties related to the normal distribution. So we remember the properties where we apply this distribution. So properties of normal distribution. Properties of normal distribution. First property, we write down as the result of symmetry the mean, median, and mode, mean, median, and mode of the distribution are identical. Identical, that are same. So that means we can say that that is mean is equal to median is equal to mode. So when mean equal to median equal to mode, so we make always a normal curve. So I always make a normal curve. So this is, so here we can see that the mean is equal to median is equal to mode. So आपने देखा होगा कि जब आपने स्क्यूनेस और कर्टेसिस पढ़ा होगा तो वहां पर अगर मीन मीडियन मोड आइडेंटिकल हैं तो देयर इज नो स्क्यूनेस इन द डिस्ट्रीब्यूशन और कर्व और अगर mean is not equal to median is not equal to mode, so we have the skewed curve. Right tail is longer than the left or left tail is longer than the right. So you remember which type of skewness. So this is right tail is longer than the left, so right is skewed. If left tail is longer than the right, so left is skewed. Okay. So here suppose we have mean, median are distinct form. So you can, so, but here in this case, mean equal to median equal to mode. So that means we can say that there is no skewness in the distribution. Now we talk about the second property. So the curve has only one maximum point. Has only one maximum point, means one peak. So curve has only one peak. So the curve is unimodal. The curve is unimodal. Unimodal means having single mode. So we can say that it has only single mode. It has only one mode. वन मोड वाले क्वेश्चंस आपको पता होगा, जैसे सपोज एग्जांपल हम लेते हैं कि 8, 10, 12, 14, 14, 16. So what is the mode of this particular series? The mode of this series is 14 because 14 is repeated two times. So repetition of highest frequency is known as the mode. So 14 is the mode or only single mode of this series, particular series. So this is the unimodal. Okay, so there are three types of mode: unimodal, bimodal, or multimodal. So here we have only single mode. Now, the third important, uh, the curve is asymptotic. Asymptotic to x-axis. Asymptotic to x-axis. So you know the definition. आपको पता होगा asymptote की definition क्या होती है. जैसे ये x-axis है. This is our x-axis. तो ये this work है जी asymptote. और now this is the curve. Okay, so sorry. So this is the curve. Just so this is the curve. So we have the definition of asymptote is a straight line. Asymptote is a straight line. So this is a straight line. This is a the axis work as a straight line. Asymptote is a straight line which touch a curve. Which touch a curve. So this is our curve which touch a curve at the infinite distance from the origin. So at that infinite distance from origin. मतलब दोनों ही लाइन कर्व भी और लाइन भी इंक्रीज हो रही है अप टू इनफाइनाइट. So at that point which touch a curve, that point is not wholly at the infinity. So that is called the asymptote line. Okay, so axis work as a asymptote line. Now, the fourth most important thing is the area. So we have the area or probability. So we discuss here at area. Okay, RCM. So the total area, we write down the total area under the normal curve. Total area under the normal curve is 1. Under the normal curve is 1. So under the normal curve, or we can say that under the normal curve, and we add here, and above the horizontal line. Under the normal curve above the horizontal line. So this is our horizontal line. This is a curve. So this area is 1. So this is essential for probability distribution. So we know that the total probability is 1. So the area under normal curve is also 1. Now we have some area. So that means when we draw the curve, so this is the normal curve. So this is our mean mu, and this side we take as mu plus sigma. That this side we take as mu minus sigma. So mu plus sigma and mu minus sigma. So suppose this is the area which is mu plus sigma and mu minus sigma. So this is our shaded area. So we do the, so basically this area is known as the 1 sigma, is equivalent to 1 sigma. So this area is 1 sigma. So now we write down the value of this 1 sigma. The area between 1 sigma is, so this is 1 sigma. 1 sigma, we can say that this probability equal to mu minus sigma, which x lie between mu plus sigma. So this is equal to, this area cover the portion as 68.27%. Cover the 68.27%. So you remember, so this cover the 68.27%. Basically we distribute the curve into 3 sigmas: 1 sigma, 2 sigma and 3 sigma. So second, we draw the curve. So when we draw the curve, so here we take as mu, so mu minus 2 sigma, here as mu plus 2 sigma. Okay, so this side will be mu plus minus sigma, or here is mu plus sigma. So now we talk about this area. So now the area for 2 sigma. So for 2 sigma, we talk about the 2 sigma. That means probability. So this will be mu minus 2 sigma to mu plus 2 sigma. So we have interval. So this is equivalent to 95.44%. 95.44%. Now we move to the 3 sigma. So we move to the 3 sigma. So here we write down 3 sigma. So this is mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, mu minus sigma, mu minus 2 sigma, or mu minus 3 sigma. So the total area we distributed into mu minus 3 sigma to mu plus 3 sigma. So our interval is mu minus 3 sigma to mu plus 3 sigma. So this area we write down as 3 sigma. 3 sigma equal to probability mu minus 3 sigma to mu plus 3 sigma, which is equal to 99.73%. And the total area we write down under the normal curve is 1, but cover the 99.73, 0.9973. Okay, so here Z equal to 3 sigma. Now, we talk about the limiting case. So we are discussing about the limiting case. So here we discuss about the limiting case. So normal distribution is the limiting case of binomial. Limiting case of binomial distribution. So we know that there are two parameters of binomial distribution. One parameter is n, another parameter is p. Okay, so here we n is very large. So n is large and p neither p or nor q is small. Okay, so depend upon this. So the probability mass function of binomial we write down as p of x equal to x successive can be written as ncx p raised to the power x q raised to the power n minus x. So this having two parameter or the value of x we say that 0, 1, 2, 3 and so on up to n. The total number of trials are n. So we take up to n. So now we calculate the standard binomial variate. So the standard binomial variate. So standard binomial variate will be, so we have the standard normal variate z equal to we write at x minus mu upon sigma. So here we write down as x minus mu. Mu is the mean. So what is the mean of binomial? The mean is np. So we write down as x minus np upon sigma. Sigma is standard deviation. So variance is equal to np into q. So this sigma equal to square root of npq. The square root of npq. So here we consider x is equal to 0, 1, 2, 3 and so on up to n. Now, so when we put x is equal to 0. So when we put x equal to 0, so this gives us z equal to minus np upon root npq. So this we can simplify as minus root np upon q, root np upon q. And when we put x equal to n, initial value, last value, so x equal to n, so then z gives us n minus np upon root npq. So this we can write down as, so we can take n as common. So 1 minus p upon root npq. So this equal to nq upon root npq. So this can be written as NQ upon P. So NQ upon P. So in both the cases, so that means this is our initial and for this case. So when we take n tends to infinity, so when n tends to infinity, so the value of z, so the value of z lie from minus infinity. Value of z will be minus, when we put n equal to infinity, so this gives us minus infinity of here also, so this gives us plus infinity. So z lie between minus infinity to infinity. So the distribution of x will be continuous distribution, will be continuous distribution because we have the interval, so will be the continuous distribution with range minus infinity to plus infinity. Hope you understand. Problem will solve in next section.